Precalculus, first 6 weeks test review. Recently we had a test in Precalculus that had about 24 problems in it, and what I've done here today is prepared 7 of these problems, which were some of the more difficult ones based on the results. And going over these problems, we hope that we can cover up some weak spots. The first problem, we're looking at problem 2. For the following function, find the approximate interval over which it is decreasing. And so we have this cubic function here, and this cubic function has a positive coefficient out in front of it. So if we graph this function, the function would look something like this. And so we're trying to find the interval from which the function is decreasing, from here on the left over to here on the right. So we could actually do this without a calculator if we used calculus, but not having the use of calculus, we're going to go ahead and resort to our calculator to make this easier. So we're going to go to, let's see, control, go back a few functions here. Okay, this is the function graph, and you can see a relative maximum up here around where x equals 1, and a relative minimum down here. And to be sure of what they are, we can use the trace feature of our calculator. And using graph trace, we have on the y-axis the cursor, and we can go to the left and find a maximum where x equals -1, and we can go over to the right using graph trace, and we find a relative minimum where x equals 5. And so between -1 and 5 is where this function is decreasing, and so we mark C as our correct answer. Now we go to problem 10. If f of x equals x squared and g of x equals x plus 2, what is f of g of x? This is not fog, it's a compositional function. So what we're looking for is we have the g, the x next to g. So we're going to take this function g and plug it everywhere we see x. And to do this plugged in, we're going to have f of g of x is equal to, okay, reserve the place squared here. We're going to place x plus 2 squared, and I think that's it. We can just multiply this out, and if we do that, we can just write x plus 2. We could use FOIL or some other method, but we're going to end up with x squared plus 2x plus 2x. That's going to be plus 4x. And then 2 times 2 is 4. So that will be our answer, letter B. Shouldn't have been too hard. Problem 11. What is the domain and interval notation of the function shown below? And I've really tried. I don't know how I could try harder to emphasize how we can calculate the domain of a square root function. Since we cannot take the square root of a negative number, we know that what's inside the radical, in this case 7 minus x, has to be greater than or equal to 0. And if we add x to both sides, we have 7 is greater than or equal to x, and we can turn this around. X is less than or equal to 7, and this is where we have that bracket, less than or equal to. It's not going to be a parentheses. It will be a bracket. So our correct answer will be A. And just to look in the calculator, in case we're not sure, we can go to this graph here, and here we see the function graph. F of x equals the square root of quantity 7 minus x. And we see the function starting over here about 7 and going to the left from there toward negative infinity. And we want to check the table view further to verify. If we press Control T, we see that here at 1, 2, 3, 4, 5, 6, and even 7, the function is defined. But as soon as we get past 7, we have an error. And so the function is defined at 7 and anything less than 7. And so this, again, verifies our answer A. 12, another domain problem. What is the domain and interval notation of the function shown below? And analytically, we know that we will have discontinuities where the denominator of a function is equal to 0. So if we can set this denominator equal to 0 and solve this equation, that's not equal to 0, this inequality. Now we can factor out an x as a greatest common factor. So we have x times quantity x minus 2 cannot equal 0. And so x cannot equal 0. And also x minus 2 cannot equal 0. This is the zero factor property. Anything multiplied times 0 equals 0. So x, adding 2 to both sides of this equation on the right, or this inequality on the right, x cannot equal 2. And so with these two discontinuities here, at x equals 0 and at x equals 2, this one down here, D, shows the discontinuity of 0 and also the discontinuity of 2. And in a graphing calculator, if that wasn't enough, we can go to Control right, and we get this graph here. We see a discontinuity at x equals 2, looks like a vertical asymptote, but going to the table view, oops, Control T, we have a discontinuity at x equals 2 and also at x equals 0. And so that again verifies that our correct answer is D. Next problem, another composition of function problem. Usually with these, we're not going to be able to use the calculator as easily. But we have f of g of x. And so we're going to take this g function and plug this function everywhere we see an x. So we're going to plug right in for this x. So f of g of x is going to be equal to 2 times quantity x plus 1 minus 3. And distributing, we have 2x plus 2 minus 3. And combining like terms, we have 2x and 2 minus 3 is minus 1. So f of g of x equals 2x minus 1, and that is our answer A. Next problem, 17. Given a function f, which of the following represents a horizontal translation of 4 units to the right? This is one, if you understand how to get left and right translations of functions, this would be an easy one that would be a 5-second problem. You just mark the right answer. but sometimes you might have a hard time remembering which one of these things makes the function go 4 units to the right. My recommendation, if you have a problem like this, is just get a prominent parent function and just start substituting in and see what happens. We can just kind of hypothesize that maybe it's this one here, answer C, because that's going to be x plus 4 inside parentheses. So we can come over here, and if we go to this function I have graphed, which is an absolute value function, this is a good type of function to use. So here it is. We wanted to find again, let's see, which one would go to the right, and we're going to hypothesize that it would be that x plus 4 in parentheses. So we go to tab, and we're going to put absolute value of, and here's the key right next to 9, absolute value of x plus 4, and that's inside the brackets or inside parentheses. See what happens. Are we shifting 4 units to the right with this x plus 4? No, we're shifting 4 units to the left. We can come back again to verify. We go to tab, and we go to absolute value brackets, and put in x minus 4, and we see that the function shifts 4 units to the right. And so our correct answer is D, shifting 4 units to the right. Shouldn't be a hard problem, but should be, even if you forget, if you use the graphing calculator properly, this is one nobody should miss. Problem 19, the last one we'll look at today, and probably the hardest one we had on this test. If f of x equals x minus 7 and g of x equals the square root of quantity 4 minus x, what is the domain of the function f over g of x? Well, what we're going to do is write this function f over g of x, and that's going to be in the numerator, f is going to be x minus 7. In the denominator, we have square root of quantity 4 minus x. Now, this is one that was tricky because if you recall from an earlier problem, I think it was this one right here, problem 11, is we took inside the radical here and set what was inside the radical as greater than or equal to 0. What some of my students forgot maybe is that this is a different situation, because this one here, if we say 4 minus x is greater than or equal to 0, we would be wrong. Why is that? Well, the reason is because not only can 4 be greater than 0, but it can only be greater than 0. It cannot be 0 because we cannot divide by 0. So instead, we need to write this inequality as 4 minus x is greater than 0. And then adding 2 x to both sides, we're going to have x4 is greater than x, which translated to be x is less than 4. So, which one is x less than 4? Well, this one here. A lot of people pick B. B cannot, the function that the domain does not include 4. And graphically, we can look at this again. Here we go to this view. Here we have the function graphed, f of x over g of x. We see that it looks like there may be some kind of a vertical asymptote at x equals 4. But we can again, we see that the function goes past 3, right? Go to Control T, and we see that at 4, the function is undefined. And so our correct answer is going to be greater than negative infinity less than 4, answer A. Well, I hope this review has been helpful and that you'll do better in subsequent tests. Thanks for viewing.